Hey folks, welcome to the DarkHorse podcast. This is a rare live stream that I am doing with Ben Davidson. If you do not know Ben Davidson, you are going to find him fascinating. He is Space Weatherman on Twitter, and we are here to discuss the matter of a ongoing solar storm, something somewhat unprecedented. We will also hopefully get into some deeper issues about where we are in the solar cycle, where we are in some larger galactic dynamics. And in any case, it's going to be quite a ride. But I should warn you all that as we are having this conversation, the dynamics of the ongoing solar storm are changing, and Ben, as in my opinion, the world's leading expert on these phenomena, is trying to keep track of the changes in real time. So he's going to do a certain amount of multitasking, and we may be finding out things as we go. Let me just start by saying, Ben, I've been following you for quite some time, and I'm very pleased to finally be sitting down with you. And I'm also thrilled that you would join me for this when there's so much going on. So welcome to DarkHorse.
It is good to be here. I have been following you on some of the other topics that I'm interested in the clown world that is unfolding around us. And absolutely, I'm going to be doing my best to multitask all of these things going on right now.
Perfect. Well, let me, I want to, maybe we should have you start by just saying how it is that you found yourself as an important voice with respect to space weather.
Sure. I have been tracking and watching space weather, solar activity, and effects on the Earth for about 15 years. I've been the lead space weather forecaster for Space Weather News and the Mobile Observatory Project for almost a decade and a half, almost the same amount of time. I have a textbook called Weatherman's Guide to the Sun, which is used in over 50 university and graduate level classes. I have peer-reviewed papers on how the sun impacts the Earth with co-authors from NASA and statistics department at various universities. And like so many other people in the world today, I took a solid foundation and applied it in basically a new information age way to understanding what's happening to our planet, since we don't really get the entire truth in the way that we should be getting the entire truth. And so those with the eyes to see and who can recognize it and who can go back and check and see who was right and who was wrong, they've flocked to many of our platforms, most of all the YouTube channel Suspicious Observers, and on Twitter, Space Weather News at Sun Weatherman. And here we are with one of the most significant space weather events in 20 years. And it is ongoing as we speak, and expected to go on for the next couple of days. But it has an interesting place in the larger picture of what's happening to our planet right now, and hopefully we'll get a chance to talk about all of that here today. And thank you very much for inviting me on. Very much
fantastic.
Appreciate it.
I'm honored that you accepted the invitation, given all the people who I'm sure would love to be talking to you about this at the moment. So let me just set the stage a little bit in terms of why this conversation is happening. For one thing, I can tell you already, people are going to be dismissive that I, as a biologist, am going to be interested in a topic like space weather. I should just point out that I have been concerned about this set of questions, coronal mass ejections specifically, since 2015, when I happened to watch a video with Arnie Gunderson talking to Matt Stein about the hazard of solar storms and the hazard that they pose to a highly technological planet Earth. And I was shocked at what they described. And as I looked more deeply into it, it was, much as Ben has said here, We are not getting the full story about the danger we are in and what might be done about it. And my experience since 2015 has been that everybody who looks into this becomes alarmed in the same way, and we all face the strange situation of watching the powers that be, which do have the capacity to make us safer, failing to react year after year. And so what we have now is an event. Ben, you tell me if I've got anything about this wrong. The basic dynamics are the following. You've got the sun, which has an 11-year sunspot cycle. We are now at a high point or nearing a high point of the sunspot cycle. Sunspots create flares. Some of those flares are accompanied by coronal mass ejections, which are essentially plasma that's flung off the sun. Usually, just by happenstance, these things are flung off in some direction where the Earth isn't. So they fling off into space and they miss us. Sometimes they hit us. And they can either hit us directly or indirectly. The amount of plasma varies tremendously. But in any case, are they satellites that are monitoring the ejections from the sun? And they are capable of telling us when a sunspot, or what I now know are filaments, has thrown plasma in a direction that it is likely to hit the Earth. There are immediate effects from flares, things that arrive at light speed and take 8 minutes. And then there are these waves of plasma which take days, not a consistent number because the rate at which they are thrown off varies. But is that all? Is that a fair summary of the general pattern?
That's pretty darn good, sir.
Right. Well, thank you. So let me just say that in 2021, I was asked by Unheard to write a piece on solar storms, and I wrote basically a scenario in which a intense solar storm led to the extinction of humanity. And when I wrote that, I did not know anything about filaments or coronal holes. I knew only about coronal mass ejections. But nonetheless, I was alarmed. And now, having found you in the last year, I know a great deal more about these topics. But in every real sense, I've become a student of yours. And you, I think, are an excellent teacher on this front. You've written a textbook. And you also put out videos that cover component topics. So would you like to set the stage for the current? We have 6 waves that arose from a particular cluster of sunspots that emitted a series of flares and coronal mass ejections while facing the Earth. That would have been starting on the 9th, or was it the 8th? It was the 8th. So do you want to explain where we are just temporally at this moment?
Sure. So on April 8th, April 9th, or I'm sorry, May 8th, May 9th, and into early this morning on the 10th, these sunspots, which were directly facing the Earth, unleashed several strong solar flares. Those solar flares pushed out a number of these coronal mass ejections of plasma, 6 of them aimed at our planet. The first impact occurred approximately 2 hours ago, and it was likely the combination of the first 2 waves. The second one caught up to the first one, and they hit together. I was watching that as it was happening, and the electromagnetic disruption to our planet was as fast and as strong as any that I have personally watched unfold in real time. We reached the second highest level of solar storm condition, which is level 4 out of 5. It appears that right now we are having the second impact, which would technically be the third coronal mass ejection since the first 2 combined into one. And we still have several more on the way. We have We slowly started to drop out of that level 4 condition over the last half hour, but we just jumped right back into it. And it is very possible we are going to hit a level 5 event here over the next day, maybe 2 days, as these waves continually hit us one after another. And it's very much like a 1-2 punch in boxing, where the jab sort of knocks somebody off their balance, and then the cross knocks them to the ground. Whereas if they had just hit them with the cross, maybe they would have blocked it or been able to take the hit and not fall down. That scenario where the more times in a row you take a whack from the sun, the more intense the solar storm is going to be. And so this is what we have on deck for the next couple of days. While it is not likely to happen, we have about a 10 to 15% chance that this will cause global EMP effects. Now, like I said, 10 to 15% means in all likelihood that's not what's going to happen, but that's as high of a risk as I've ever seen, or that I've ever seen known about. And we are already seeing less than global effects. So that would be localized and regional disruptions of various networks and systems, everything from power companies to gaming networks. Google was having issues. Amazon Web Service was having issues. The U.S. Postal Service website went down for about half the country during the first impact, during that rapid pulse I was mentioning. And so this is a really big wake-up call for a lot of people. And at a larger scale, it's an excellent test to see how Earth handles these things, because there's only one thing standing in the way between that global EMP, what they call the solar kill shot, which would basically send us back to the Stone Age, and the sun. And that is Earth's magnetic field, the magnetosphere. The problem is it has been weakening, and it's continuing to weaken at a relatively rapid pace. This is part of a cyclical magnetic pole shift that happens on our Earth. Unfortunately, we are undergoing one right now. We have been very lucky to ascend from the beginnings of civilization up to where we are now, basically in the time since the last one up to now. But it's happening again, and this, while again, there's only that tiny chance that this will be the solar kill shot scenario. This kind of solar storm, if it had happened 20 years ago, we would not have reached level 4, and we would have no chance of reaching level 5. So we are already seeing this being yet another example of how the sun is causing excess geomagnetic or electromagnetic disturbances to our planet. And this has been going on for the past several years, but most extremely the last year or so.
So
to the point where
I want to slow you down a little bit, because you've covered you've briefly covered a bunch of topics, and it's going to sound far-fetched to anyone who hasn't looked deeply into the model that you have built up. So in any case, I think probably the best role I can play here is a little bit as translator, as somebody who has spent time with your material and has thought about what you're proposing. You know, for example, I think we all infer from the fact that we have not experienced a dramatic, destructive solar storm-based event in our lifetimes, nor do we know of one in historical times. We have the sense that, well, okay, maybe these are a theoretical problem, but they're not really a problem for us. And there are a couple of reasons that that's just not right. For one thing, there is an event that people who follow this know well, called the Carrington event in 1859. Now, 1859 is an interesting year. Lots of stuff happened. That's the year that Darwin published The Origin of Species. But in any case, the world was not a highly electrical place in 1859. What did exist was a telegraph network. And the telegraph network, again, you tell me if I've got any of this wrong, but the telegraph network was highly excited and disrupted by the Carrington event, to the point that operators were shocked at their stations, that even though the network was disconnected from power, messages could be sent over long distances because of the electrical excitement in the wires from the solar storm. And there were fires. Am I correct that there was instances of fires? So if you imagine a world in which very little is electrical, but what was electrical went haywire, and then, fast forward to 2024, not only is the world highly electrical and highly integrated and dependent on electrical systems, but it's electronic, which means that we're talking about now very sensitive devices on which our lives depend for everything from the ability to travel from one place to another, to know where we are, to keep goods flowing to supermarkets. So all of our systems have components that are jeopardized by what you're calling the global kill shot EMP type effects. Fair so far?
Correct. Absolutely.
All right.
And, there were several other smaller events. In 1921, we had one that was not as big as the 1859 event, and it completely shut down the New York rail system. In 1989, there was an even smaller event, but it took out power to the entire province of Quebec. The most recent significant event was called, it's known as the Halloween storms of 2003. Right around Halloween in the year 2003, we got a very big solar blast that hit the Earth, and several transformers exploded in Sweden and Norway, and several grids went down in South Africa for a matter of days, and they had to do a significant amount of repairs. And so more recently, in 2022, a solar storm took out about 40 Starlink satellites. We have seen small network disruptions since, in some of the events of just the last couple of years, but we haven't seen anything like this come to Earth probably since the Halloween storms of 2003. And of course, we are significantly weaker in terms of the planetary magnetic shield right now than we were back in 2003. And, like I briefly mentioned earlier, we're in the very beginning stages of this. There's still multiple waves coming from the sun. We are already seeing tons of network issues at the moment. They all went down at the exact same time. All of these system glitches that I'm seeing here all happened at the exact same time, and it was when we got this incredible magnetic pulse, which also hit harder and faster than any I have ever seen. And so it's a very real thing. It's a very real thing, unfortunately.
Okay, so let's get to, I want to cover two issues separately. One is the hidden hazard of the transformers, and the other is your point about the decreasing magnetic field. So let's start with the transformers. And again, I'm just going to, as a layperson who's become interested, I'll tell you what I think I know, and you tell me what's wrong with it. The grid depends on these transformers to get electrical power to everything. These transformers, however, are vulnerable. They can be made, you tell me if they can be made immune to EMP-like effects, but at any rate, we have transformers that have not been made immune, and even to the extent that they might be somewhat immunized by taking them offline, nobody wants to make the decision to kill the electrical grid for a low probability of a disaster, because then they will be blamed if no disaster happens and people have been without power, what they will see as needlessly. So the transformers sit there vulnerable, and at the point that they are destroyed by one of these solar storms, the problem is they are not something that can be easily sourced. My understanding from back when I wrote my piece in 2021 was that if you ordered one just under normal circumstances, it would take at least a year and maybe up to 3 before it was delivered. If the world suddenly needed many of them, it has a catastrophe on its hands. So the lights could go out in some big portion of the grid and not come back on for months or years. And that compounds the damage that would be done by the storm itself.
Yeah, that's pretty accurate. I would say the only thing is they can't be completely immunized against this, but they can be hardened to the point where the level of solar storm that would be the baseline that would cause a transformer explosion can be jacked up a couple of levels by some hardening. Nobody on Earth is doing this. Nobody is really hardening these things. And if we get that really big punch, there's no amount of hardening that's actually going to stop what's coming.
And it has always struck me as strange that we aren't hardening them, because my understanding is that the cost to do this, while it seems large, what I remember from 2015, from the video of Arnie Gunderson and Matt Stein talking, was that the price to harden the American grid would be less than the price of a B-2 bomber. You know, it's little enough that nobody would notice it in the gigantic national budget. And there's also nobody making money from us being vulnerable. So it's literally in everybody's interest that we fix this vulnerability, and yet decade after decade we do not. Is that fair?
Well, we've seen a couple instances recently where it didn't seem like it was in anybody's best interest for things to unfold the way that they did, and yet that's how it happened. In fact, 2020 and 2021 was a very good example of that. That maybe is a bit more on the periphery of the focus of this discussion. We could get into it later. But the problem is that would just be to harden the transformers. And if you recall with the Carrington event in 1859, a lot of the electrical wires caught on fire. They would literally have to not only harden every transformer, they would have to replace every electrical wire, all the cable networks, both above the ground and under the ground. They would have to completely redo all of the power stations as well. And then we're starting to talk about basically rebuilding America from the ground up. And, you know, so that's not only the power lines you see across the street, but that's the wiring inside of every building and every home and everything like that. So we're talking something relatively substantial, to the point where, you know, it would take decades and maybe trillions of dollars to do it at this point.
Well, you know what? That sounds really bad. On the other hand, I've met a lot of people, and I don't think most of them are ready to live in the Stone Age. So I don't really see an alternative. And I am hoping, you know, the risk of the current storm is so large. As you point out, it's, you know, it's not likely to take us out. It's much more likely that we will get through the weekend and still be here on Monday. But the risk is so unacceptably low. I mean, you put the risk of what you're calling the solar kill shot, as of this morning, you put it just a little bit above 10%. You know, that's a little bit like playing Russian roulette with a revolver with 10 chambers in it, right? And it, you know, chances are you'll get away with it, but you wouldn't be smart to, and yet here we are.
Exactly.
So,
exactly. And so you'll have people looking at the scenario and being like, oh, it's only a 10% chance. And then you have other people who are more like me and be like, how many weekends are there that come by where there's a 10% chance of the world getting thrown back to the Stone Age, which would kill several billion people over the next 3, 6, 12, 24 months, just because of how dependent the world is on electricity. And, you know, we're talking, and if you can't immediately pull that one up in your head, not only is it no power for your home, for hospitals, things like that, there's no heat, there's no electricity, there's no gas, there's no ATMs, there's no refrigeration. Within 3 days, there's no food at the store. There's no water distribution, there's no water purification, there's no 911, and there's nobody coming to help.
Yep.
Because it's everywhere. And that's the kind of thing where the first winter, maybe half the world dies. And when you factor in the lack of food production, food shipping, water purification, water distribution, medical services, other critical infrastructure. The most conservative death estimates are something like 90%. And this is the kind of thing that could completely wreck our civilization.
Oh, it could drive us extinct pretty easily. My impetus to write the piece I wrote in 2021 was largely about the interaction with nuclear power, in which we have a system in which nuclear power plants require electricity in order to keep them from melting down. And there's a contingency plan for plants that are cut off from power, but that contingency plan is for weeks, not years. So it's not hard to imagine scenarios in which one by one, each of the plants is abandoned because it can no longer be managed. Right? If you've got to keep those plants actively cooling and they stop cooling, and what happens is you get fuel pool fires and meltdowns, then nobody's going to be able to work those plants, and that means all that material is going to get spilled out into the world. Now, it's a little hard to say how devastating that would be to a higher life, but it would certainly, if you imagine that 90% of the world would succumb to cold and starvation from a solar catastrophe, and then add to it the fact of nuclear radiation being spilled out of all 400 civilian nuclear reactors, things get pretty bleak. So I think extinction is definitely on the table if we don't harden our civilization carefully.
Certainly. And, of course, the problem is we have to think of something to do with these nuclear power stations anyway, because with the magnetic field doing what it's doing, the solar kill shot is only a matter of time. Now, there are some things that could be done. So, for example, while the power is down and you're in that few days to few weeks time of emergency power, of backup stuff, you take the rods out of the reactors and, as Galen Windsor said decades ago, you can hold a certain amount of uranium in this hand, you can hold a certain amount of uranium in this hand, nothing happens. You put them together and you're going to die. And, they can be broken or taken apart, but, I don't think that these protocols are actually in place, or if they are, I don't know about them. But, things like that would need to be put into place, and there would need to be people who understood and were charged with going in there, taking the rods out, and if need be, breaking them into smaller pieces so that they weren't as imminently radioactive as they could be.
I'll go you one better. We've got the issue of the rods in the reactors themselves, and we've got the issue of the rods in the pools. Now, one thing that I think is obvious is that anybody who is aware of the danger that the sun, especially in light of the weakening magnetic field, which we will get back to shortly, anybody who's aware of the full magnitude of that danger, though, should be advocating to take all the fuel from the spent fuel pools that is cool enough to be put into dry cask storage, and it should go there immediately. Now, that still leaves us with a bunch of fuel that needs active cooling. I think it needs active cooling for something like 5 years after it's removed from the reactors. But there's a lot that's stored in these pools that isn't within that 5-year window. It's just been stored there because it would be expensive to put it in, or comparatively expensive as the nuclear industry sees it, to put it in dry cask storage. And that means it's all vulnerable. So we could reduce the vulnerability greatly by taking the stuff that is cool enough to sit in an unactively cooled vessel, and we could put it there. That would be greatly helpful. And yet, as far as I know, there's no movement on that front either. So, yeah, we're taking unnecessary risks is one of the important points that I hope people take away from this podcast. But let's talk about the magnetic field, because this is a place where your work just simply departs from the the standard model that people are aware of in a way that is alarming and predictive. The idea that the field is weakening is not a mystery as to why it's happening. You have a model that predicts that it would be happening now. Do you want to describe that model so people understand it?
Sure. This begins with surveying all the times this has happened in the past. And interestingly enough, the one that happened most recently was the very last one to be discovered. And this is just in the last 2 years. Discovered and confirmed. So the
discovery happened in the last 2 years.
Yes. The discovery and then the confirmation of it happened in just the last 2 years. And the other ones that they've discovered happened a long time ago. But so the very last one that was discovered, the very last one to occur on this planet was about 6,000 years ago. Now, keep that number in your head. The one before that, 12,000 years ago. The one before that, 18,000, 24,000, 30,000, 36,000, 42,000, 48, etc. About every 6,000 years, and every second one, every 12,000 years, is a really magnanimous event. It's an even worse event. Well, the last really worse event was 12,000 years ago. The last one overall was 6,000 years ago, so we are due in time for this magnetic pole shift right now. Should be happening. And what do we see on the planet? The magnetic poles are shifting, the magnetic field is weakening. Now, we've been looking at this for quite some time, and there were a few instances in various different scientific fields, whether that's how the sun is affecting the Earth with a solar storm similar to what we're dealing with this weekend, to interesting things that are happening in the atmosphere, and that's everything from here in the troposphere, down low where we all are, all the way up through the stratosphere, the mesosphere, the ionosphere, which is an electric layer that sits basically on the top of the sky. These anomalies are growing at every layer of the atmosphere and in terms of how the sun is impacting the planet. But about a year ago, to be more specific, about 13 and a half, 14 months ago, we started noticing that these things were going off the charts. It started in late April of 2023, when literally what you would, if I could metaphorically put this, a gust of wind, a breeze of wind from the sun acted like a hurricane. The amount of electricity that it induced into the ground was unfathomable. It caused a plasma penetration into the upper atmosphere that was so severe. This is what they are actually calling it in the peer-reviewed scientific literature: a new and unprecedented type of geomagnetic disturbance. The problem is, there was nothing new or unprecedented with what the sun did. It was mild at best, and this happened over and over and over again last year, and it happening again this year as well. 2023, we broke the record for most low-latitude auroral sightings in any year ever. And the thing about that is, it should be getting harder to see them because of light pollution. As time goes on, we should be seeing fewer and fewer aurora. Last year, we broke the record. And not only is that concerning, the sun did not do anything fantastic. Yes, the sun was more active in the 11-year cycle, but there were no major events that came to Earth, and yet the aurora are off the charts. Plasma is penetrating through our magnetic shield to the point where they have to declare new and unprecedented types of geomagnetic events. Things that 10, 20 years ago would have caused either no geomagnetic storm or maybe just a level 1, a little instability, are causing level 2, 3, 4 storms. And we spent the majority of the last 6 to 8 months saying, guys, this is precisely the type of sign that we are looking for, that we have hit an acceleration point. We've hit several acceleration points, and I guess we'll go back into that in just a minute. Every sign was there that we have hit one of these acceleration points at some point in 2023. Now let's hold that thought. This really kicked into gear, interestingly, back in 1859, the same year as the Carrington event. That's when the magnetic poles, which are always moving around slightly at the north and south, really began to take off. There was a major acceleration in the middle of the 1900s. There was a major acceleration around the year 2006. There was a minor acceleration in the year 2020. And then, just 5 weeks ago, one of my favorite, and in my opinion, one of the top 10 geophysical scientists in the world, a Russian by the name of Dr. Sergei Semenenko, he published a paper describing a severe, the worst yet, magnetic anomaly in March of 2023, which marked the spot of the acceleration of this ongoing magnetic pole shift or geomagnetic excursion that, again, is due every 6,000 years and is due right now. With this information, we were no longer speculating about what has happened over the last 13 or 14 months. The data is now in. We had a major acceleration in March of 2023. It is the reason why we are having new and unprecedented types of geomagnetic disturbance. It's the reason why we're breaking auroral records. It's the reason why this weekend there is a 10 to 15% chance that we're going to get the solar kill shot, whereas 20 years ago we would be saying, hey, this is kind of significant. If you get a chance and there's no clouds in the sky, go outside, see if you can see the northern lights. This is going to be quite the wallop we're taking for the sun. But we're on another level now with this, and it's because, as we had been guessing for the last 6 to 8 months, the magnetic field, the magnetic pole shift is accelerating, it's weakening, and we are basically on a pretty solid downward spiral. In the year 2000, we had lost 10% of the magnetic field since the middle of the 1800s. So about 150 years to lose 10%. They updated that to 15% in just the year 2010. So 150 years to lose 10%, and then just 10 years, and we've lost another 5. The European Space Agency came out and said, we have gone from losing about 5% per century to 5% every decade. Now, since they said that, nobody has come out and updated that number. It's pretty easy to speculate based on everything that, all the data that we have, but the European Space Agency, NASA, the World Center for Geomagnetism in Kyoto, Japan, everybody just went silent on exactly where Earth's magnetic field is now, to the point where for most of the last couple years I was telling people, guys, we have to be down at least 20 to 25%. With this acceleration that we had in March of last year, we could be losing 5% every 5 years or every 2 years. And we're starting to get to the point of that criticality, the tipping point. And there was a very fantastic paper written on this not long ago. It's called Rapid Geomagnetic Changes Inferred from Earth Observations and Numerical Simulations. This was published in Nature. And they said that when we hit this tipping point, the Earth's magnetic field will be changing 100 times as fast as it is now. Now, that was back before the recent acceleration. When we hit that tipping point, that could be at any time in the coming years. We will have only a few months left until Earth is basically without its protection. At that point, any little thing from the sun is going to throw us back to the Stone Age like that. And that's why we're making such a big deal of this, even though we don't think this weekend will be the one. I am using this as a learning opportunity because what we're getting this weekend, I know when something like this happened in the past, several times in the past, I know what to expect. We've already well exceeded that in terms of the solar storm levels. We've exceeded it, and we're not even halfway through this solar storm event right now. And so how much longer until something from the sun just completely knocks us out?
Oh.
And that's the bigger picture and the bigger problem with what's going on at the moment.
All right, so let me see if I understand. Some of this is well familiar from having read your work, and some of it is a bit new. But the connection between the pole shift and the weakening magnetic field is basically, as if the poles are stable, then the field can be strong, but as they cross through the equator, they become disorganized and they lose their protective impact. Is that somewhere in the ballpark?
Sort of. It also seems, for reasons that we don't fully understand, it's not like it's just a shield that gets holes in it. It seems like the planet actually weakens electromagnetically, and then once the poles...
All right.
Nowhere near as important as the fact that it's going to happen. And it's what happened in the past, and it's what's about to happen in the coming years as well.
Got it. Okay, so let's add another dimension to this. I will say as I learn about this topic, especially from you, who seems to know it in many different dimensions, I'm often troubled by the education that I received in school. I was certainly made aware that the poles shift, and that I could tell you how we know this, that we can basically look at magnetically aligned particles in stones and we can see where the poles have shifted because they align the particles in a different direction. Okay, but nobody ever told me that the flipping of the poles was a regular event. If I had known that it was, I knew that it happened sometimes, but if I had known it was a regular event, the obvious question would have been, well, what is the periodicity and why? Now, at the point that I learned from you that it is a regular event and that the periodicity is known, this 6,000-year cycle, you also present a model of why there would be this periodicity. So can you describe why it is that the Earth has a pole flip on a 6 minor, 12 major 1,000-year cycle?
Sure. But to do that, we have to start by learning that Earth isn't the only planet that's doing this right now. There are changes. Every planet in our solar system, there are changes on the sun. There are changes that they are noticing in the interplanetary space between the planets. To quickly run them down, in 2018, Pluto lost a fifth of its atmosphere in 12 months. Neptune is having a major cooling event, and its major storm patterns have reversed. To give you an idea of what this means, imagine hurricanes forming off the coast of Florida and shooting eastward across the Atlantic and slamming into Africa. Literally, just the major storm pattern on Neptune just reversed, which is not supposed to be possible. Both Uranus and Saturn are having record auroral and storm activity. Now, before we go any further, the loss of the atmosphere. Why did Mars lose its atmosphere? It lost its magnetic field. How are you going to change and reverse an entire weather pattern on a planet? You flip its electromagnetic scenario. Why would there be record auroras on Uranus if the sun isn't doing anything spectacular? Well, maybe the sun's just got an easier shot at it because its magnetic field is changing. Saturn, there's a 30-year superstorm. Every 30 years, a major storm happens on Saturn, and it happens at Saturn's closest orbital point from the sun. You know, Saturn doesn't go in a perfect circle. There's one point in its 30-year orbit where it's just a little bit closer to the sun, and when it hits that point every 30 years, a superstorm develops. The last one came 10 years early. Why? Its magnetic field is changing. More solar energy is getting in, and it tricked the Saturnian atmosphere into developing that storm early. We don't have to make such inferences as we come in a little bit further to Jupiter. Yes, we could, by the fact that the Great Red Spot is diminishing. There's a new great red spot called Red Junior. The cloud bands are shifting and there's storm anomalies all over, but we don't have to make that inference there because we can directly test Jupiter's magnetic field. There are electrons trapped in its powerful magnetic field that basically sing a song in radio waves, actually very close to FM radio waves, throughout the solar system. And just a couple years ago, that song began to change. So either the nature of an electron has changed at Jupiter, highly unlikely, or the thing driving its activity, which causes the magnetic field to sing that song in radio waves, has changed, meaning the magnetic field of the planet has changed. Let's move in even further. With a very quick search of the internet, you can find that Mars is undergoing equal climate change to Earth, if not more. But not only that,
it's politically less divisive on Mars.
Definitely politically less divisive. But more important to that is we landed a craft there called InSight, and it had the ability to monitor seismic activity, and it did so, but it noticed that the seismic activity was just getting stronger and stronger and stronger, and all of it was in excess of what they believed the Martian planet was capable of, to the point where now it is mainstream science today that, oops, we had it wrong about Mars all this time. It's not geologically dead. The mantle is alive and active. And you can look this up on the internet. Mars mantle active, Mars mantle alive. And they say, oh, we just got it wrong. And I don't think so. I think Mars woke up. Mars woke up.
Interesting. So it sounds to me, did you just name 8 of the 9 planets?
I can keep going.
Well, I'm
because
yeah. Oh, so you haven't gotten to Venus and Mercury yet, is that right?
Correct. And obviously we have all the changes I described on Earth. Venus, all we have is that its fastest winds are getting faster for some reason. 33% faster. Earth's fastest winds are getting faster due to climate change, but only about 2 to 5% faster. 33% at Venus. The only sphere in our solar system we don't have information about is Mercury. Now, the Mercury Messenger satellite went by several years ago and took detailed information about its magnetic field. Bepi Colombo is arriving there now and beginning its studies. When Bepi Colombo's data comes in, we'll be able to make the same magnetic judgment about Mercury. Coming in one more time to the sun, the coronal chemistry is changing. The amount of helium is on the rise in the solar atmosphere, and its magnetic fields are changing. So that's literally every sphere except Mercury that we can't say that it doesn't have it. We just don't have the data yet to say whether or not it does. All the spheres, and in the interplanetary space, they are noticing extra charged particles. Not from the sun. They can tell they're from the galaxy. Extra neutral atoms. And most importantly, there is more dust than there should be, and it's going up over time, from the sun all the way out past Pluto. And all of these things, including what's happening to the Earth, are happening for a reason. The same reason right now. All right, now, so what did you want to jump in there with before I go any further?
So I was just going to try to lead you to connect the dots a little bit here. You've got every sphere in the solar system is behaving in an odd way. You've just mentioned, and so I will say that just scientifically speaking, of course, we have to leave open the possibility that we're just getting better at detecting stuff. I know that there's evidence that that's not what's going on, but nonetheless, the fact is we're measuring lots of stuff, so the fact that it might be changing could just be that it's always changing. But if we put that possibility aside for the moment, you've got changes, measurable changes in all the spheres of the solar system, but Mercury, where we don't have data to say one way or the other. You've got extra solar system dust. You've got galactic dust. So it's like the solar system is moving into a cloud of dust, and it's dustier in the solar system than it would be. And those things point in the direction of something that causes the entire solar system to have different conditions at different times. And the interesting question is, Ben, how do you connect that with regular periodicity, right? We've got changes in solar conditions across all of these spheres but Mercury, and we've got a periodicity that is unexplained. What unites those things?
Thank you for asking. Whether they're studying the solar wind from our sun, whether they are doing electric experiments in a lab with a sphere magnet, or whether they are looking at the entire Milky Way galaxy and now several other nearby galaxies, every spinning sphere magnet in an electric field creates a ripple. Now, this ripple comes out from the equator. So if you've got a spinning magnetic sphere in a lab, the ripple is going to come out like this. They detect this in the solar wind going through the equator of the solar system. That hits Earth about every 5 to 7 days, and it's usually not that big of a deal. But it does cause the magnetic field that we detect within the solar wind to flip and flip back and flip and flip back. Again, this doesn't have a titanically huge effect on the Earth. But when you think about what this means at a galactic level, and not only have they studied it,
so wait, I
the
missed
magnetic
a step.
field
it's on
of
me,
the solar wind.
The thing that flips every, did you say 5 to 7 days?
It's the
That's the sun is rotating, because we watch the sunspots come in at the left, move across the face, and disappear on the right. It's rotating in an analogous way to the way Earth rotates. So that rotating sphere in an electromagnetic field is causing this wave, and the periodicity of that wave is, you said 5 to 7 days. Is that right?
Approximately 5 to 7 days at Earth's distance. And basically what it means is we go from being exposed more to the sun's northern magnetic fields and then the sun's southern magnetic fields, northern and southern. Now, they have spotted this at the galactic level as well. Several galaxies. They've spotted it, including our own Milky Way. In fact, they know the amplitude of that wave in the Milky Way. It starts off smaller and then gets bigger as it goes out, from 60 parsecs tall to about 180 parsecs tall, which is, more than 100 light years in both directions. So it basically encompasses the entire galactic disk. Even though it's not completely flat, it's not so wide that the vast majority of stars are not getting hit by this rippling outward wave. They also know its thickness. They know that the galactic current sheet, whereas in our solar system they call it the sun's current sheet or the heliospheric current sheet. They know that the galactic one is tens of light years thick. And they think it's moving somewhere between 700 and 1,500 kilometers per second outward.
Okay.
That combined with the amplitude tells us it should be hitting Earth at some point, depending on which speed you choose, between every 5,000 to 7,000 years. Right in the middle, there's about 6,000. But more important than the fact that all of the physics says it's there, it should be hitting us cyclically. Let's think about scaling up what we experience in the solar system version to what our solar system experiences at the galactic version. People who talk about a galactic magnetic reversal think it's about going through the equator line, but that's not the case. That's not what happens here in the solar system, and that's not what they detect in the laboratory. It's whether or not you're on the north or south of that wave. And so if you're at a stationary point here, You don't have to move north or south. As the wave passes you, you will have a galactic magnetic reversal of an entire system. So that's starting to explain the magnetic aspects. But here's the other thing. This magnetic reversal point is housed within this sheet, which is an electric sheet. And it is sweeping outward radially through the galaxy. As it's doing so, it's picking up dust. It's picking up dust like an electrostatic Swiffer duster in your home. It's picking up extra neutral atoms pushed along by that dust, and the magnetism and the electric sheet itself is picking up extra charged particles. The charged particles, the neutral atoms, and the dust are exactly what you would need to see. In addition to these magnetic changes throughout the solar system, in order to say, okay, this is working from both sides now. They know it exists in the galaxy and other galaxies as well. They know it has to hit us cyclically. They know this is where the magnetic reversal point is. Here in the solar system, we're basically having a solar system magnetic shift. We're seeing the extra neutrals, charged particles, and dust that you would expect from it. This is the evidence you need from both sides. But there's a cherry on top of this sundae. Because you see, this rippling sheet, according to their physics, should not have the electromagnetic buoyancy to be sustained all the way throughout the galaxy. It needs injections of extra energy here and there. The only way they can make it work are if they somehow include super flare and small nova-like events from the stars that are being hit by it, which will inject it directly into that electric system to sustain it all the way through. Now, this is a problem because there is a 6,000-year super flare cycle on the sun that is beyond anything that scientists normally think about. In fact, this was just discovered a couple of years ago, I think maybe 2019 or 2021. Let me see. Super flares. It's called Statistical Properties of Super Flares on Sun-like. Yeah, there it is. Statistical Properties of Super Flares on Solar-type stars. And I'll just go ahead and I'll read this. I'll read this to you right here. The analysis suggests sun-like stars. The analysis of the sun-like stars suggests that our sun can cause super flares with energies ... up to X 1000 class every 6,000 years. Okay. Well, that's concerning.
Yes,
because
to say the least.
The Carrington event of 1859, and that was somewhere around X 80. Normally, they think something around X 50 would be a solar kill shot. With the weakening magnetic field, that's probably down, if we're talking about one event and not multiple combined. With just one event, you probably need something above X20, X25. And on this exact same 6,000-year cycle, the sun produces an X1000. And it's probably a little closer to a micronova than a super flare. Now, this is where most people become exceptionally incredulous.
Yep.
What are you talking about, Ben? What are you talking about? But this is where the science has been more on my side than just about anywhere else. Should I keep going?
Yes. Let me just say, I'm not going to become incredulous on you. You've established your credibility to discuss well, I've lost my train of thought, but somehow you have the credibility to propose models that sound fantastic. But as a biologist, I will say, I do have a doubt. Heather and I have discussed your work extensively, and I do have a doubt as we get into this part of your model, based on the fact that things that you see up in the area of micronova and crustal shifts, which we have not yet discussed here, are hard to square with the number of existing species that we have and the locations where we find them. So in any case, I'm absolutely open to hearing the evidence on this, but there is a part of me that thinks the Earth wouldn't look the way it does if catastrophes on the scale you're talking about were a 6 or 12,000 year recurring phenomenon.
Well, so all right, let's we can certainly get to that. Something in terms of a super flare, or let's go with micronova from the sun, and that would actually probably only equate to about an X100 or X200, maybe up to X1000.
So for those who aren't familiar with X, the flare that released a CME this morning, I woke up to an alert from the Space Weather Service. What's it called? So people who want to sign up.
It depends on which one you're using.
I can't remember, but in any case, what we saw this morning was what, an X5, was it?
X3.
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 Yeah.
Okay, so that gives you some sense. X3 is pretty large. X is the largest class, and within there, the number tells you the magnitude, and X3 is enough to give one pause, but it's nothing like X20 or X100 or so.
Correct.
Go on.
So the solar micronova, there are some indications that this has struck the Earth on these cycles. In fact, specifically on those big ones every 12,000 years. A man named Doug Vogt has done a very good job with pulling together and aggregating the information on fission tracks in microtectites and fossils. And some of the isotopes you can't make with a meteorite, you can't make with a volcano, you can't make them in a nuclear reactor. You basically need a nova-level event on the sun. So then that opens the door to at least asking the question, all right, is there something that could make the sun have a little nova? Well, up until April of 2022, the entire world of the mainstream science said, Ben, there's no such thing as a micronova. It doesn't exist. Then in April 2022, they announced, we've discovered micronova, a new kind of nova. By the way, one of 8 new kinds of nova discovered in the last decade. I've made several videos called They Don't Know Nova, and they really don't. And since that time, they've discovered dozens of micronova events, and they're getting better and better at it. But so the question is, all right, what makes a star do this? Because it's very different from a supernova where the star itself explodes. Most micronova and most regular nova, for that matter, are actually recurring events where they go once and then they can go again. There are only 2 things in space that can make a star pop, shed off its outer skin like a snake violently, and cause this micronova. One is a magnetic kick. It needs some kind of a strong magnetic punch. Or you have to dump material onto the star such that it's like blocking the vent or closing your hand around a firecracker. I don't know if you remember that scene from Armageddon. You light a firecracker in your hand and you set it off. What happens? Burn your hand. You close your hand around that firecracker and your wife's going to be opening your ketchup bottles the rest of your life. I believe that is the quote from the movie. But so those 2 things, you either need to have a magnetic kick or you need to dump material onto the star. Well, what's happening to the sun right now? We are getting a magnetic kick from the galaxy.
So because we're passing through the magnetic sheet.
Current sheet.
Yeah.
And we're getting extra material dumped onto it.
That's
in the form of dust, neutral gases, and those extra charged particles.
Because they've accumulated at the sheet. So you expect these things at the same time. Like snow on a shovel blade through space. And so the only 2 ways that we know of
to make a star micronova are happening right now to our sun at the exact same time. It is the only way to explain the nova level isotopes in the geology here on Earth, and it's the only way to fix galactic astrophysics and re-inject that energy into the current sheet because of that electromagnetic buoyancy problem. It literally solves 3 problems in one. And now you have to say, okay, this sounds very scary. Now, this is where we could look into things like the sun going dark in religious or mythological stories, and other things like, or how many ancient civilizations were literally terrified of the sun. And of course, that's more circumstantial. But on top of that 3-way coincidence, what else do you call it? I mean, you can't explain the nova level isotopes on Earth.
So wait, let's unpack that for people, because most are not going to understand it. The problem is that all of the heavy elements in the universe have to have been produced through fusion. And there's no mechanism for fusion to happen unless you have immense amounts of gravity to drive the nuclei of the constituent elements together and cause them to fuse. And even that only produces elements in the lighter part of the periodic table. You need incredible pressure. You tell me if I've got anything wrong here, but you've got to have the incredible pressure created in some kind of a nova event to create the heavier elements. So when we find elements that are heavy, and we know something about half-lives and how quickly they ought to expire, we can say, well, there must have been the conditions necessary to produce these things within this time period, or we wouldn't have this amount of material. So we can say there must have been some nova-like event, or we don't have this material here, and yet it's here. So there must have been a nova-like event. Is that fair?
That's fair. And those, again, are accumulated in microtektite glass and fossils on those 12,000-year marks. And we really don't find much in between them, except for what is a more constant raining down of, say, iron-60. And we know that's produced in nova events from stars, but that's also at a constant raining down from space. It's all throughout the galaxy. These accumulations occur right on the 12,000-year marks. And
could they have come from somewhere else?
Almost certainly not. Because while the light from other nova events can get here, there's almost no chance that these are coming from other stars' nova events, because most of their particles are never going to get here. We can look out and we can see nova events that happened thousands and thousands of years ago. And yes, they're beautiful nebula, but it's not like they are spread out throughout everything and everywhere. They're coming on a cycle, and that would be hard to do if it's coming from some other star. The particles probably would never get here. And even if they could, they have half-lives that are too short. It would literally take millions and millions and millions of years for them to get here. There's just no way. It could be coming from anywhere other than the sun.
Okay, so what you've got here is a very strong case that you've got materials created in nova-like circumstances that must have come from our own sun.
Correct.
And you have the observation of micronovas on sun-like stars. And so the logical conclusion that you're deriving from this is that our sun does that. And it appears to be on that 12,000-year cycle.
Yes, and in addition to what we've been talking about that geologic evidence, there are 2 ways they know how to make them in space. They're both happening to the sun as this cyclical galactic current sheet hits. The sun's biggest outburst cycle is 6,000 years. Sort of makes sense that, every second one would be something even greater, perhaps at the micronova level. And things like this happening are the only way to fix the galactic astrophysics. So we went from geological to astrophysical, And now, remember, there's that galactic physics problem where there's not the electromagnetic buoyancy to sustain the current sheet unless the stars that are hit by it are re-injecting energy back into it. So it literally fixes several aspects or open questions in the science. It matches the cycle. It matches the mechanism of forcing that triggers this. It fixes the galactic astrophysics, and it answers the questions about the nova level isotopes here on the Earth.
Well, that has the sound. This is unfortunate because that has the sound of a correct model. When not only does it answer a question, but it answers a bunch of adjacent questions. That's a glorious thing if you're trying to figure out what's going on, and it's a frightening thing in this case because it implies nova level events very close to home.
It does. And I have woken up every day for the last 3 years and scoured the scientific literature and the observational data for something that tells me that this idea is wrong. And at this point, I'm just getting up and looking for the kick in the teeth at this point. You've never met somebody who wants to be as wrong as I do. And maybe one day we'll find it. But at some point, you can only have so many coincidences of physical evidence and timelines and cycles and mechanisms of forcing and interaction of and convergence of all of them from a planetary, stellar, and galactic physics perspective before you say, maybe these aren't coincidences. Maybe this is legitimate.
Well, I remember the first time I encountered the diagram that you use of the galactic current sheet. And suddenly the periodicity made sense. And the fact that it derives from the most simple observation about this rotating mass in a field. And the point is, well, the galaxy is obviously rotating. Even the just distribution of stars tells you that it's doing that in the same way that the sun is doing it. And so the idea that there should be a periodicity to it, I wouldn't be in any position to know what the period is, but the idea that there's a 12,000 year and a 6,000 year, well, really it's a 6,000 year periodicity, is very intuitive once you have just a few basic physical facts. And that's really, again, that's the hallmark of a powerful hypothesis, is that it assumes very little. What it assumes is secure, and it explains a great deal, right? The fact that many observations are explained at once by your model, and that it doesn't require very much to be true in order for us to see it, that has the ring of truth to me. Now, let me ask you this. The picture you have painted suggests that two things happen simultaneously as a result of the fact that the solar system is moving through this galactic current sheet and encountering effectively the wall of it, or the equator of it. I guess it's not the equator, but it's the wall of it every 6,000 years. And that is that the extra dust that is thrown onto the sun and the electromagnetic kick that the sun experiences that increases the chances of some sort of a nova level event comes at the same time that same property is reducing the electromagnetic field of the Earth. It's kind of like the universe is setting us up.
A little bit. There's no creation without destruction. Things rise and things fall. And here's the thing. Yes, it is going to be terrible, but we're still here. This will probably kill a lot of the life on our planet. Hasn't taken us out yet. I mean, even though it does seem to be an intensification of biological loss and the extinction of species. Now, there's dozens of papers on this. My favorite is one called The Role of the Geomagnetic Field Intensity in Late Quaternary Evolution of Humans and Large Mammals. And they basically show that at these magnetic pole shift events, these excursions, this is when we get the biggest bulk of extinctions, especially when it comes to megafauna. It's been tied to the Neanderthals as well, although it's likely they were already well on their way out due to their interaction with more modern Homo sapiens. But if there was a nail in the coffin, there was a nail in the coffin. But we are still here. We're going to be here after this one. And so as scary as this is, the fact that, even some of these latter details we're talking about, I'm not sure they matter as much as the fact that this is a cyclical magnetic event that happens to our planet. Forget the solar system, forget the sun. This is happening to Earth, and it's got significant impacts on the ozone, the climate. For some reason, it causes volcanic upticks every single time. This is in the literature as well. And it causes extinctions of species. Probably because of a combination of the climate impacts, the loss of the ozone, and the extra radiation overall that we'll be subject to as our magnetic shield weakens. And so we need to be asking, all right, how do we survive this? Because clearly we survive it every time. And that should be an encouraging, epilogue we're shooting for to this relatively terrible story.
Yeah, wouldn't it be cool if we stopped dicking around pretending that viruses leaping out of the forest was a major hazard to humanity, or that anthropogenic climate change is the greatest threat that we face? Wouldn't it be great if we focused on this, what appears to be an actual threat that continues decade after decade, which we are making vastly more dangerous by the way we have built our technologies and come to depend on them? This really is the opportunity to come together. You don't need an asteroid headed for the Earth. The threat, the call is coming from the sun, right? It's coming from right here, and preparing for it. This is a tremendous opportunity for humanity to recognize that we are all down here, on this pale blue dot facing the same threat, and that we're really going to have to put our heads together to do something about it. Why aren't we doing that?
That is a conversation I would love to have over bat soup. This is the kind of thing where science fiction writers should be out of a job already. Like, what are they going to come up with that's better than what's actually about to happen? This is like the cosmic version of the Super Bowl.
Yeah, it is. When I wrote my piece, I should just say that my piece, I went back to it just to remind myself what I had said, and I was shocked to discover that in the first line, I had said that the world began to end on May 12th, 2024, but it would be 309 years before the species finally went extinct. And it was like, I don't even know what to think about that, that we are enduring a major electromagnetic storm at this very moment. But in any case, so
I should probably check.
When I wrote it, it kind of wrote itself, because the fragility of our civilization is such that it wasn't hard to get from, a major portion of the grid going down to unrecoverable chaos. So anyway, yes, yeah. I think your point about science fiction writers don't need a whole lot of material beyond reality at the moment is certainly right.
I couldn't agree more. And, there are so many things about science that thinking in these terms can help alleviate. So, for example, this notion that everything around us is the result of millions and millions of years of the slow crawl of geologic processes and wind and rain. I'm going to say this as simply as I possibly can. They don't have a freaking clue how old anything is. For example, there's an Australian meteor crater that they thought was about 200,000 years old. They went back and they did a different isotope test and found, nope, it's over 300,000 years old. That's a pretty big error. Now, there's tons of examples like that in the data, but my favorite one, if you go to any search engine and you type in Tibetan ice caps krypton, the very first thing that's going to come up is a paper called Krypton Dating at the Gulia Ice Cap Tibetan Plateau. And just listen to these numbers. Based on chlorine and oxygen dating, they believed these ice caps had to be more than 500,000 years old. So the youngest they could possibly be is 500,000, probably much older. Then they went and they did krypton dating. They found the upper limits of the age range, possibly as low as 15,000 years, meaning it could be younger than 15,000 years. Just by changing which isotope they're using, they went from older than 500,000 to maybe it could be as old as 15,000 years, maybe less. They don't have a clue how old things are. They have no idea in the world. And that honestly knocks out, I'd say, 75 to 80% of the fossil arguments against the crustal shift, which is the final part of this whole thing. Literally, just that one fact that they don't, like, they're very good at categorization of taxa and species and other things like that. They don't have a clue when something died. No idea when it was living on this planet.
Well, let me ask you about that. So, do you think radiocarbon dating is... the problem is radiocarbon dating doesn't take you very far back. But do you think radiocarbon...
No, about 50,000 years?
Yeah, I've forgotten how far, but it's not, it's not a very long time, so It only goes so far. Do you doubt radiocarbon?
Not in every case, but in many cases, yes. I remember that story about the seal that was caught in the net of some fishermen, and they carbon dated it to 650 years old. But it had died that morning. I have serious doubts about some of the carbon dating. I have doubts about oxygen and chlorine dating. Argon's a little better. Krypton is rock solid. Nothing is as good as using these nova-level isotopes with nearly perfect half-lives, and that can't be modified in any way. So let's take carbon. You know the number one way they discover major solar flares in the past?
I don't.
There's spikes in carbon production. Every time there's a major solar event, there is a spike in the carbon data. And so since discovering that, and since discovering the major ones in 1859 and the big one in 994 AD and 774 AD and some of the ones in the first couple centuries to millennia BC, nobody's ever gone back and redone any of the carbon dating with this new knowledge in mind. Nobody's ever done it. And they just let these dates persist, knowing that every big outburst from the sun completely wrecks the timeline on the scale of years to centuries in terms of how much carbon there is in a thing. And so bringing this back to the pole shift, there's a guy named Major Maynard White who gave data to his son to write a book after he was out of the military. It's called World in Peril. He committed a felony. He kept classified data from Project Nanook in the Arctic. He kept classified documents from the Pentagon. He kept classified reports from the Rand Corporation. And he gave them all to his son, Ken White, to publish in this book. And basically, at that time, the government's analysis and the scientists in Project Nanook, their analysis was, we've got the Earth tilting 90 degrees and tilting back because we're up here in the Arctic digging down and we find a layer of polar fossils, then tropical fossils, then polar fossils, then tropical fossils. And you add that to the mammoth problem I'm sure you've heard of the mammoths that had to be close to flash frozen with food in their mouths and stomachs that was undigested. And yes, that is a great mystery, but that's not the great mystery. The great mystery is, what were they eating? Because I'll tell you what, where they find those mammoths frozen in the ice now, there's not enough vegetation there to support them right now. And we're 12,000 years into an interglacial warm period. These things were frozen in a glacial period. If there's not enough food there now, don't tell me there was enough food there during a glacial cycle. It's because they weren't up at high latitudes back then. They were thrust there as the Earth tipped over. The greatest mystery of the mammoths is not, how do you freeze one so quickly? It's, okay, what were they eating at that latitude in the middle of a glacial cycle?
All right. Well, let's just say I find your explanation of how you flash freeze a mammoth terrifying, but plausible. But again, as much as I understand the model you're arguing for, where the crust and the mantle become unlocked from each other and there is a major shift, there's a part of it that's very intuitive. But again, the biota of the Earth are hard to square with a shift in latitude that is that regular and that short a periodicity.
So I do hear what you're saying. I also know that the amount of evolution they have seen on some reptiles that they have taken onto some islands in the Mediterranean in the span of 30 years, they thought would take 12,000 years or 20,000 years or 100,000 years. Again, this biota, I don't trust the dating of it. I don't trust it one bit. They don't have a clue how long it's been there. They don't have a clue when it was alive.
Well,
that, and every part of the Earth changes so rapidly. If you've got the Earth going like this, you've got these areas over here that are just spinning. They're not changing latitude at all.
Well, okay, so let's tease this apart a little bit. Okay, first of all, I don't want people to lump all of the various types of claims together, because I think
sure
the astrophysical model is so elegant and so predictive that it would be a shame to hang it on the biological part. They may both be right, but I wouldn't fuse them together because you don't, a major error in one of them doesn't falsify the other. So, with respect to what we know about how long ago species diverged, you are quite correct that is a dicey business that is fraught with assumptions. On the other hand, you have things like there was a sort of old school excursion by a biologist by the name of Paul Collinvaux, who went to the Amazon to test the question of whether or not the Amazon periodically became a grassland during glaciation. And so what they did was, and this, I'm remembering this from decades ago, so if I've made an error, forgive me, but I believe the work involved pollen cores that were taken from anoxic sediments in lakes in the Amazon. The idea was that pollen tells you what plants were present, and if the Amazon changed radically and became a grassland, you'd see very different pollen. And pollen, unlike something like a molecular clock that would tell you how long ago two genomes separated, pollen is very nice because every year you get a burst of pollen and its sediments, and so you get strata like tree rings. Tree rings are very likely to be a reliable counter because every year you have a growing period and you can see it. So Anyway, the upshot of that experiment, if I'm remembering it correctly, was that the Amazon did not show signs of being anything other than a tropical forest, that it did not show this periodic shift into grassland.
It successfully showed it did not transition into a grassland. However, if you were to say for 12,000 years, all of a sudden dump ice onto it, cap it somehow, and then rapidly melt it away, bring back the rainforest, there's no sedimentation on top of the last pollen that came down. And it's just going to pick up right where it left off. And so it's kind of like the issue of, there's some scientists that are arguing in Antarctic ice cores right now, okay, is this line one winter, or is that one snowstorm? And so, yes, I agree. That study and I think I know which one, and there was actually a series of them. It came out, and yeah, I agree, it was never a grassland, but that doesn't mean it wasn't capped off and insulated from other kinds of contamination, to the point where if it melted off rapidly and the same kind of plants were there and the seeds woke back up. I mean, did you hear the story a little bit ago about the olive trees and the grapevines that they successfully grew from seeds that had been in the ground for like 2,000 years?
Well,
there are some.
It's funny, when I my graduate work was on biological trade-offs, and one of the things I was interested in was the latitudinal diversity gradient. And anyway, I got deep into studying glaciation, why it happens, what its impact is on species diversity, that sort of thing. And I ended up coming to believe that a great many species have glacial contingency programs, that they have abilities to endure, to get through long, extremely hostile periods and wake back up. And I remember there was doubt from my colleagues, but I had one mentor, Jerry Smith, who was he was an ichthyologist and a paleontologist. And he encouraged me on this front. He believed actually there might well be something to it, and that he encouraged me to pursue the idea that evolution could see very long periodicity. That was my belief, and he thought there was something to it.
Love the way you're phrasing that. That's brilliant.
So anyway, let's put it this way. I had the slightest inkling back then that there was even a question about the crust coming unglued from the mantle and shifting around. I was simply thinking about a static relationship between the crust and the mantle and Milankovitch cycles causing glaciation. But if you take that idea and you simply say, well, the thing about which creatures would have to evolve around isn't the one you were expecting, but the same principle applies, I can see it. But then it predicts, that you would be able to discover, especially among the plants, that they would have the capacity to be dormant over long hostile periods and wake back up. You know, if you discovered that, that would be consistent with your model. I do wonder about the animals. Obviously, you could tell a story about creatures like birds, you know, that they have a contingency program that allows them to migrate to wherever the hospitable place is. But even that, if I imagine the crust shifting by 90 degrees, it's a long...
That's only on one longitude. That's only on one longitude. The further you get away from that line of shift, to the point where you're 90 degrees away, there's no change in latitude at all.
Well, let me ask you this.
It's just
Is it always the same shift? Or does that place where you get a 90-degree shift move around between episodes in your model?
That's tough to say. We know that the evidence, if you go back in the ice cores, suggests that when it flips back, the poles, the current North and South Pole, are always relatively there. But there's evidence of the North Pole being in Wisconsin. I have a belief that the Bermuda Triangle and the Dragon's Triangle are previous poles, and it's magnetized that part of the crust so much that that's what the Bermuda Triangle and the Dragon's Triangle are.
So just to see if I understand. So you're arguing you get a concentration of anomalous magnetism, and instruments on an airplane are more likely to screw up, that kind of thing?
Well, I mean, to be honest, I don't exactly know why the Bermuda Triangle acts the way it does. All I know is that it's a magnetic anomaly. Same with the Dragon's Triangle. And it's basically the Bermuda Triangle of Asia. There's one over there, too, on the opposite side of the planet. And, you know, there are... I'm glad you mentioned that you don't necessarily need this crustal shift for the rest of this stuff to be accurate. But I do know this. Those documents that Major Maynard E. White kept and gave to his son are pretty darn convincing. The idea of there being alternating tropical and polar fossils in this one area of the Arctic that has been off limits since the first time they've actually discovered this stuff. Nobody's allowed to go there and start digging. The idea about the mammoths, that one's really hard because, again, where they find these things, they couldn't survive there right now. They could survive the temperatures, but there wouldn't be enough to eat. No way there was enough to eat during a glacial cycle. And then you combine this with, you know, some various other things that are just hard to explain unless there's some form of a crustal shift. Maybe not 90 degrees, maybe something closer to Charles Hapgood's idea, which is only, 7 to 12 degrees. But it's the kind of thing where something major is happening to this planet. And the one thing that we know happens with these events all the time are mega tsunamis. The surge deposits that they find are absolutely bananas. At the bottom of the Gulf of Mexico, there's evidence of sand and other things that has to have come from the Pacific off the northwest USA. In Alaska, there's surge deposits that are literally mountains of muck and fossils and trees and bones and dirt. And I don't know how you create these mega tsunamis if you don't have a crustal shift, or at least a lot of up and down movement of the crust. I agree, if there's enough mantle heaving from getting zapped with a micronova that the mantle literally goes like this, okay, all right, yeah. But, I got to find a way to explain that evidence I mentioned before and the mega tsunamis. And to be honest, I can't think of a better one than the pole shift. And, we were talking about all these coincidences with the micronova. The new pole positions have an even more ridiculous one, because forecasts of the new pole positions go back to before they knew about the magnetic field changing right now. And they suggested that the new poles were going to be somewhere in South America and somewhere near India. It just so happens, as the magnetic poles are shifting right now, they're not staying on opposite sides of the planet. They are converging towards India. It just so happens the other side of the planet is the South Atlantic magnetic anomaly in South America, the weakest point of all the fields whatsoever. That's an interesting coincidence. Here's the other thing. When Einstein did this math, and several others, with Charles Hapgood 80-something years ago, 70 years ago, and he said it looks like the crust shifts, he knew that if you could unlock the crust from the mantle, and he died not knowing how you did that, it would be the weight of Greenland and the weight of Antarctica, the part of it that's south of Australia, that would pull the world over. If those are the things that pull over to the equator, it happens to put India and South America in the perfect places. And so that's three coincidences, the pre-science predictions of the pole position, where the magnetic poles and magnetic anomaly are now, and Einstein's math about how we would shift, all give the same story of the new pole positions. Then you've got the mammoths, Major White's evidence, which he, thank God, stole from the U.S. military and the Pentagon. And the idea of, okay, that explains the mega tsunamis. It's my leading candidate to explain this. But I'm glad you said it. Even if that's not what happens, great. Thankful. Let's take that one off the list and figure out how we deal with the micronova radiation and the loss of Earth's magnetic field. I would love that.
Hear, hear.
That'd be fantastic.
Okay, two more things before I let you go. One,
sure.
Do you want to look at maybe you've been doing it, but do you want to look at the active incoming data and tell us where we are now?
Yeah, so, Jiminy Christmas. So we have exceeded level 4 and got 2/3 of the way to a level 5 solar storm. This is the biggest one in my 14 years of watching. There has not been a level 5 solar storm since the Halloween 2003 event. Looking at the solar wind, I have to revise what I said earlier. We have not even taken the second impact yet. We are 5 hours into the first impact.
And the first impact is the two first flares, the CMEs from the first two flares combined?
The first 2 or 3 that combined. At 6 hours, let me do math. At 5 hours, it could be 3 CMEs combined. But it still means we would have 3, and again, possibly 4, still coming over the next day or 2. And luckily, we're getting a little bit of a break.
Okay. So
not much of
the last of the CMEs, as of this broadcast, the last of the CMEs that we know are headed our way was released in the middle of the night, early in the morning, this morning. When
Correct.
Will that have passed for sure?
I would still expect that one to hit on Sunday.
So we're looking at this weekend, and if we don't get any more flares that send CMEs in our direction, we will be out of the woods for the moment.
We have 3 coming in the next 2 days.
Okay.
3, at least 3, maybe 4 coming in the next 2 days. We have already hit KP 8.67. And at KP 9, you're at a level 5.
Got it.
That's
all right.
That's a lot.
Well, that's fascinating. If you see something before we're finished here, please let us know.
Absolutely.
People should certainly sign up for your Twitter account, Space Weatherman, and where they can get this updated. You, in fact, do a show every morning. You're a couple hours east of me, so by the time I get up, you've done a show that tells me if anything's happened in the last 24 hours. It's very interesting, and you definitely will get a crash course in the language and style of thinking if you pay attention to these things every day. The last thing I want to ask you is, in terms of, there's obviously a lot of stuff, we've talked about a bunch of it, that civilization could be doing better in terms of preparing. But as far as individuals go, I know that you are also an extremely careful, thoughtful prepper. And I know, as somebody who has thought a lot about prepping and tried to do it, that it's complicated to figure out how to prioritize and what you should be doing with respect to protecting yourself from these solar storms. So can you talk us through a little bit about, does it make sense to flip the main breaker on your house if you think something is coming? Will that protect it? Can you put objects into a Faraday cage and protect them? What do you do?
So I am, in the long run, preparing for a world without electricity. Even if I protect this device or that device or my house, when this eventually happens and all the grids go down, they're not coming back. So there's not going to be any power. There's not going to be any more batteries once my batteries run out. What's more important is that we have the short-term and long-term means to not die, which is, in the short term, that's food, extra water, making sure that let's say this happens in January. Make sure you don't freeze to death when there's no power and there's no heat. That could be a combination of firewood, extra blankets, extra jackets, fortifying the clothing that you have, things like that. And because these things could go on for days, weeks, maybe even months until things come back in the shorter term, unfortunately, you need a way to protect yourself. And for me in the United States, I'm very pleased that we have the Second Amendment for that. There are other options in other parts of the world. But it gets a little more complicated on the long term, because you need to actually start thinking about, do I know how to hunt? Do I know how to plant? Do I have seeds? Do I have pre-industrial tools? Because I'm not going to be driving my tractor around. It's probably going to be fried, and what am I going to do? Make my own gasoline? No, that's not going to happen. And so there's the question of, okay, if the power goes out for 3 days, what do I need? If the power goes out for 1 month, what do I need? If the power goes out and doesn't come back, what do I need? And that's everything from food, water, seeds, tools, and lots of books. Nobody can memorize everything that's going to be needed in this, but books, not only is that an important thing to preserve, but they will be your lifeline for everything you don't know how to do and haven't memorized.
Yep.
And yes, guns and bullets.
That seems to me a very good list. But I'm still interested, given that there's effectively a range of catastrophic scenarios. And the ability to get through, let's say you're facing your first winter and the power is not coming back on, but you can stockpile, let's say, some gasoline to run a generator for a small number of items that are electrical. Is there a way to protect electrical objects from a massive EMP following from a solar storm?
There's not in all cases. This is like the transformer thing we were talking about. You can do some things like maybe put them in a Faraday cage, maybe unplug them, maybe put them in plastic or in something rubber where the induced current is not going to jump it. It's the reason why wires are coated in plastic. If it's the big one, you're not saving anything.
Yep.
But yeah, so everything from plastic, and I don't mean like plastic wrap. I mean like those plastic bins where you're like, kids, put all your baseball gloves and soccer balls in the plastic bins in the garage kind of thing. Or something rubber, or a Faraday cage, something like that. In theory, if it is not the mega event, yes, you could save some things. And of course, they're only good temporarily. But yes, the answer is yes to your question. That can work for a short period of time.
And what is the fate of solar panels in a major EMP?
Not good. Amazon once had a plan about 7 or 8 years ago. They were going to put solar panels on the roofs of every single warehouse and not need to be connected to the grid. They stopped that very quickly because they kept catching on fire every time there was even a minor solar storm.
Really?
They are so vulnerable, especially if there's a bunch of them in sequence together for some reason. But if we're talking about a big one, yeah, that's tough. I mean, if you have all the pieces completely disassembled and in plastic containers or rubber, and you know how to literally put the thing together and hook it all up in the aftermath, you're welcome to try it. But if these things are not protected and they're actually out and in use, they're done.
Okay.
They're going to be done.
And vehicles. I know I've seen a little bit of work you've done on taking a very old vehicle and hardening it for survival purposes. Suppose you had an intermediate vehicle that does have some electronics but is primarily old school. Is there anything that can be done? Are there parts that you should stockpile in a Faraday cage and could resurrect a vehicle?
Well, I mean, it all depends on what level you're talking about. I mean, you're not going to need a radio.
That's certainly true.
But the things you have to look at are alternators. What is the starting mechanism? A spark plug is going to be one of the first things to go, which is why on the vehicle you're talking about, Rocky's Big Burb, we put in an air starter to the point where, we can electrically fill these tanks up with air. We can also crank them.
Yep.
And so, alternators. And I'm actually not the car guy, but for people who know how to do it, if you've got your basics in order, like you've got your food, you've got your water, you've got your seeds, you've got all that other stuff, and you're like, all right, well, I'm prepared. What do I do now? And you know how to start looking into the electrical components in your car, go for it. Absolutely, go for it. It's worth doing anything in the right sequence on the list. If you don't even have the first thing stored in terms of extra food or water, and you're trying to figure out how to make an EMP-proof vehicle, got some priority issues there.
Yeah. Prioritizing is obviously the first step, and I would point out, again, the hard part about this style of thinking is that you're dealing with scenarios, everything from minor disruptions, where having enough batteries for your flashlight is important, to flash frozen mammoths where there's literally nothing you could do if you were on the wrong side of the globe at the wrong moment. So you've got that entire range. And my feeling, back when I was a professor, I actually taught a program called Lights Out. And the idea was, what if the power went out and it never came back? And at the time, I didn't know as much about how that could happen as I do now. But one of the lessons of that program was that there are sort of two kinds of preparedness. There's preparedness for figuring out how you're going to bootstrap the production of all of the stuff of life on your own when civilization is no longer functioning. And then there's, how are you going to get through a 2-year period in which people who didn't prepare at all are going to suffer the consequences of that. And if you can get to the other side of it, then you will erect community and together figure out what to do. And that shorter period of time is amenable to putting aside the right kind of stuff that's easily available in the functioning world that won't be available at all in the post-functioning world. And so anyway, I do think that, how you prioritize depends on which sets of, you should always throw out the scenarios that are the hardest to survive, because the point is you'll spend everything trying to survive them and it probably won't work and they probably won't happen anyway. So if you can just take them off the table and say, look, given a survivable scenario, right, what would I want to have available? What increases my odds? And so I'm very interested in that level of insight. So let's say that you were trying to preserve a vehicle. Could you park it in a shipping container? Is that a Faraday cage sufficient to protect a vehicle?
I would not want to have anything I wanted inside of a shipping container. The induction of electricity during the micronova or powerful solar flares. Not only is it going to turn it into the oven, but you could have lightning bolts sparking from side to side inside of a shipping container.
I'm glad I didn't invest in a shipping container.
I would prefer a root cellar or something like a bunker that doesn't have a whole lot of metal.
Okay.
If you've got a basement with no windows and no walkout doors, okay, maybe that's okay. But you really do, and this is something from from the underground shelters in Cappadocia to the cave dwellings over here in Colorado Springs, the evidence that people used underground to survive these things in the past is unbelievable. And yes, they were adopted in more recent times by smugglers and underground railroads in various parts of the world, but they were constructed to survive these issues thousands of years ago. And there's definitely a lesson in that, even if it's just a root cellar.
Yeah. My wife and I went to Turkey for our honeymoon, and we went to Cappadocia, and the structures you are talking about it's almost impossible to describe what was excavated. I mean, you literally have a city underground where clearly thousands of people and their livestock were able to survive for long periods of time. And the story that we were told about that was about marauding hordes. But of course, that's speculative. And the idea that there might have been climatological conditions which drove people underground is in retrospect, that would make a lot of sense too.
Yeah, and there's no doubt that a lot of these places underground were adopted and used in later years by thieves, smugglers, marauders, things like that. Those kind of people don't build like that.
Yeah.
You don't get a band of criminals who's like, hey, you know what? I'm sick of stealing from people.
I'm going to start digging.
I'm going to start digging. I'm going to do some hard, honest work for the first time in my life, and it's going to be this. No.
Yeah.
That doesn't
I agree with you.
So for most of the people who are listening to you, here's some things that are hopefully inspiring. The people who don't really have our best interests at heart, they chose the United States of America to move their global power to. And in terms of where they're going to get their food after this is all over, there's no seed vaults at the equator. They're all up north. Doesn't make sense unless they know something. Move the global power to the United States doesn't make sense when they have owned Rome forever, unless they know something we don't know. And so there's with the exception of some of the mountains in Mongolia, I give the United States and very select parts of Europe very high chances to survive. It's worth trying. It's definitely worth trying.
All right.
And
go ahead.
And worth avoiding random injections into your body for things that you hear about on the news.
Oh, yeah. That one has become very clear. And I will say, I hate to think this way, but there does seem to be an awful lot of building of elaborate hardened structures by people who have tons of money. And the obvious interpretation is that they're expecting something. So the degree to which the topic of solar storms and the hazard they pose to civilization is not discussed is conspicuous, right? You don't have to believe the full story that we've described here in order to think this is something very serious and worth preparing for. And yet we discuss it, more often than not. All you hear is expect northern lights. So I would add one other thing that I've learned from you that I think is a hopeful note, which is that if I understand the pattern correctly, the most severe catastrophes on this 6,000-year cycle don't tend to follow each other. And we have been
correct.
We have been through a bad one most recently, which means that this one is likely to be more survivable at a climatological level.
And so we can say that persists back over 100,000 years. The Blake magnetic pole shift and excursion was bad. That was more than 100,000 years ago. Then there were just a couple that were kind of bad until 70,000 years ago, which included the Toba eruption, which may have left as few as 100 reproducing human females on the planet. Next couple weren't so bad, and then Le Champ about 40-something thousand years ago. That was bad. Le Champ was bad. The next couple were not as terrible. The one 12,000 years ago was bad. It wiped the Americas clean. We know that there were animals and people and all kind of stuff here before, but we had to repopulate this continent. It was bad 12,000 years ago, which suggests that this next one, even though it is the 12,000-year cycle, will not be as bad as some of the bad ones we've had in the past. Like, everybody should be encouraged. Nobody should be giving up. Everybody should be, okay, we're still here. I am the descendant of a survivor. It's in my DNA. Let's figure out how to do this.
Yeah, that's a great way to think about it. I would say we've added the hazard of technology, and that's really where our focus should be, is that taking the part of this that's a self-inflicted vulnerability and taking it off the table would be extremely wise.
Couldn't have said it better myself.
All right. Well, Ben Davidson, this has been fantastic. We've told people to find you at Space Weatherman on Twitter. That's your handle.
Sun Weatherman on Twitter. Most people watch the YouTube channel Suspicious Observers. If you start just looking around, you're going to find that people have a problem with my science like they have with your views on COVID and the vaccine, like they have on Alex Jones' views on, well, everything. But to be honest, that's good company. So I would say Suspicious Observers is the place on YouTube to find me, or on Twitter at Sun Weatherman. Space Weather News at Sun Weatherman. But Bret, thank you so much. This has been wonderful talking to you. I really appreciate you having me on.
It's been great, and I appreciate all that I've learned from you, and I appreciate your doing this. I will also say that your books are very worthwhile. You should find your level. You've got books for people who are highly technical and well-versed, and you've got other books for people who aren't. And people should figure out what level they're at and order your books, because they can educate themselves very quickly on this topic.
I would agree with that.
All right.
Thank you.
Well, thank you, Ben, and thanks everybody for watching, and good luck. Hopefully we get lucky once again, get through the weekend, and then we can start talking about how to make civilization less vulnerable to solar weather.
Absolutely.
Thanks. All right. Be well, everyone.